Hi everyone! Let's create a simple algorithm that allows us to remap the colors of our scene to a predefined palette. This effect can be useful if, for example, we want to simulate the screen of an older device that only supported, say, 256 colors and similar scenarios. So let's do it. This time, there's no need to go into a complex theoretical explanation, so we'll jump straight into programming. I'll start by creating a basic scene with a screenshot from our game in the background. So right-click, create new scene, let's call it palette, okay. Click and I'll take the screenshot, drag it to the scene so the sprite 2D node was automatically created, and in the inspector I will disable centered in offset, and in transform position I'll reset position to 0, 0. Okay, let's scroll down to the material section and create a new shader material. Click and create a new shader, which is called palette GD shader of canvas item type. And as usual, I'll put it to the shaders folder and create, and click again to open it in the shader editor. Alright, and as always, we'll delete everything unnecessary because the only thing we need is the fragment function. So I'm deleting vertex and I'm deleting the commented out light. Alright, so first we need a color palette. Essentially, we have two options for obtaining it. Either we add an array of predefined values to the code, or we generate it using a function. I've decided to go with the second approach, as it seems more flexible to me. However, we can always rewrite this code later to use a fixed array of RGB values. So, a function it is. I've used something like this several times before, and it will be useful this time as well. The function works by returning a color based on input parameters. 4 of them are also colors, and the last one is a float number that works as an index. It looks like this. Vector3, palette, and input parameters float t, this is the index, and then vector3 a, vector3 b, vector3 c, and vector3 d for colors. And we simply return this value, a plus b times cosine of tau, which is twice pi, times c times t plus d, and that's it. This is one of the common functions to create a palette using these parameters, and as I said, I will use it before, and you can find it in many other shaders. Very well. So the parameter t can easily be provided as the color index in the palette, and we will define the 4 input colors as uniform parameters. I will set their default values to colors that produce a fairly good result, and we can change them later. Let's do it here. So uniform vector3 color A with the hint range source color, so we'll get the color picker in the editor, and the initial value I'll set to black 0, 0, gray 0.5, all components. Now let me copy and paste 3 times, 1, 2, 3, and rename it to B, color C, and color D, and this initial value will stay the same. Here I will change it to 1, 1, and 0.5, and the last one would be 0.8, 0.9, 0.3. Let's just fix the values in the inspector. Okay. In addition, we'll need 2 more parameters, palette size and palette step. The first, as the name suggests, will determine the total number of colors in the palette, and the second one will allow us to control the value of the t parameter for greater control over the resulting colors. Let's do it here. uniform float palette size with a hint range and the initial value. For example, let's start with 32 colors, and it would be from 4 is the reasonable minimum, and the maximum, let's set to 1024. And the step, of course, is 1. 1. All right, and the second parameter, uniform float palette step with a hint range and the initial value, I think 0.5 would be okay. And let's make it from 0.1 to 10 and the step 0.01. Very well. Now let's dive into the fragment function. Since we are not creating any symmetrical patterns or concerned with the aspect ratio this time, we'll stick with the standard UV coordinates. We'll get the color of the current pixel and prepare a variable for the resulting color. Here we go. So let's call it vec3 pixel, for example, and it's a result of the texture function applied on the current texture, which is our background image, and the standard UV coordinates, and we need only vector 3, so RGB components. Okay, and then the final color, let's prepare it. Vector 3 color would be, the initial value is simply a black color, and we will display it. Color is vector 4, color for the first 3 components, and 1 for alpha. Okay. So we don't see anything yet because the resulting color is always black. The algorithm we'll use now involves finding the closest color from the given palette. Since we are working with vector 3, we can use the distance function, which returns the distance between two vectors. But first, we'll add a variable min_dist, which we'll set to sufficiently high value, like 1000, and then we'll reduce it in the loop. So let's do it in the fragment function. After the color definition, let's define float min_dist, and as I said, 1000, 1e3, which is short for 1000. Okay, and now the loop, where we'll go through the palette and search for the optimal color for the current pixel. Each time the distance function returns a value smaller than what we've achieved in previous iterations, we'll set the color to the current value from the palette. Let's do it. So for float I from 0 to palette size, our parameter, and I++, the cycle vector 3, let's call it P, as is the color from the palette, is the result of the palette function with this parameter I multiplied by palette step, our second parameter, and I think it is still too high, so multiplied by 0.1, and then color A, color B, color C, color D. I'll just copy and paste and change it. Color B, color C, and color D, semicolon. Okay, and now the distance function. So float dist would be the distance function applied on P and the pixel value. So now we are trying to find the closest color from the palette to the color of this pixel. And let's check if it is really the closest one. So if dist is less than the actual min_dist, let's assign a new color. This current color from the palette is our current color. Okay, and of course we need to update the min_dist each time. So min_dist is just the minimum of the current dist and the previous min_dist. Okay, let's wait for it. And here we go. That's actually it. Let me just expand. Okay, right now we can see the original image converted into a 32 color palette. We can zoom in on a part of it like this lamp and to better see the color transitions. So we can see that these are really some color maps that were not visible before. And the palette step parameter, this one, plays an important role in fine-tuning the final appearance of the image. We can see that when its value is too small, like I think it, too small, the resulting colors are very close to each other, making the outcome practically unusable. A similar issue occurs if the step is set to value too high, like this. Okay, let's reset. It's always necessary to find the optimal balance between the number of colors and the distance between them in the palette, or by adjusting the palette itself using the 4 input colors. We can experiment with this a bit. So, for instance, I don't know, let's change the palette size to 207. Now, if we reduce the step or increase it, we can see that there's definitely a larger number of colors used. Or let's, for instance, change the colors. Like this one could be something reddish, or is definitely not too usable. But I think if you play with the parameters for a long time, you should definitely find something that is suitable for your particular image or scene or color palette. Okay, of course, in the case of a predefined fixed palette, none of this is necessary. On the other hand, when we are then limited to a single color choice, and if we want to make changes, we would have to do it directly in the code. It depends on which implementation works best for a specific case. Thank you very much for watching. If you enjoyed this shader, I would be grateful for any likes or subscribes. And if you manage to achieve a nice result, I'd love to read about your parameter settings in the comments. For now, take care, good luck with your projects, and I'll see you in the next video.